factor 6x squared plus 11x minus 10. Okay, can you tell me what would be your first step to factor this? Okay, I lost your, you need to speak a little louder.
Thinking now. I think I would put 2 on the outside, maybe, and then do 3. No. I'll do that.
Okay. So you're looking for two numbers. When we multiply them together, you get 6x squared, right? So.
Yeah, but I'll put the x on the outside by itself, or I should put. Yeah, I should do that. I should put x by itself because none of those get you 11. Wait, no.
Okay, let's stay with the first term. The first term is 6x squared. Obviously, we're going to have x and x here, right? That's obvious. So for 6, your possibility would be 1 and 6 or 2 and 3, right?
Yes.
So let's try 2 and 3. Now, you're looking for two numbers. When we multiply them together, you get minus 10. And that's the number we're going to put here. Again, the possibilities would be 1 and 10 and 2 and 5, right? So if you put 5 here and 2 here, you want to see if that's the right combination. Let's say you make a mistake. Well, let's see what we get here. 3 times 5. What is that? 15x. And then that would be 2 times would be 4x. Can I make 11 out of that?
Yes.
Yes. If this is plus and this is minus, right?
Yes.
So what makes that plus would be this term here. What makes that minus would be this term here. And if I multiply the last two terms together, plus 5 and minus 2, that give you negative 10. So everything is there, right?
Yes.
Now, if you selected 2x here and 3x here, and let's say you switched it around, you put 2 and 5 here, and then that would be 2 times 3 would be 6x. This would be 10x. Can I make 11 out of that? No. So that means, okay, that means that I might have to switch this around to make it correctly, like right combination. Does that make sense?
Yeah.
Okay. So that's how you can factor. And sometimes maybe the combination 2 and 3 may not be a right combination. Then it might be 6 and 1. So you have to look for that possibility also. So there are degrees of trial and error involved with factoring, and the more you do this, the faster you can come up with the right combination. So if I say factor, that's what we do here. Now, if it's instead of a factor, if I say solve, let's say I want to say solve, same problem, except I just have to have an equation here. So if I ask you to solve this, then I have to let it be equal to maybe 0 here, right? So now if I factor them again like I did earlier, then how would you solve for x?
I guess I would what do you think? I have no idea.
Okay. If I have 2x plus 5 times 3x minus 2 is equal to 0, how do you solve for x?
I think I get it. If you did multiply the 2, then you get 6x minus 10, and then you subtract, you add 10 to both sides, so then you take the 6x and put it divided by both sides?
No. You still have to do factor it like we did here. You factor it first. After you factor this, how would you solve for x? You have 2 terms equal to 0. So either 2x plus 5 is equal to 0, or 3x minus 2 is equal to 0. Does that make sense?
Yes.
Okay. So you basically have to let each of these parentheses be equal to 0 and solve for x. So that should be 2x is equal to -5, right? You subtract 5 from both sides, so x is equal to -5/2, or 3x is equal to 2, so x is equal to 2/3. Do you follow that?
Yes.
Okay. So once you factor it, then you let each of these parentheses be equal to 0 to solve for x. If I say solve, if I say factor, you're done. You just stop right there. So you see a difference between factor and solve now?
Yes.
Okay, good.